Well, congratulations everyone, we've hit week 12 and we finish off with a bit of problem solving, mostly in word form. Let's start out. Firstly, it's word form and only one variable. That is in, there's not x's and y's and z's or anything like that, it's just x's or just n's or whatever, just a single unknown. Now, we get to what is the cost of buying n oranges at 90 cents. Now with questions like this, these are just little parts of an overall bigger word problem. But it's easy to get it wrong. It's easy to just get confused. Like, what's the cost of buying n oranges at 90 cents each? Am I thinking is it 90? Oh, let's go for a pen. Down here. Let's press that button. No, that one. Yeah, that one. Is it like 90 n? Is it 90 on n? Is it n on 90? There's all sorts of combos I've seen that, people just sort of try and come up with. But I think the best technique is to just make up an answer for n. Like, if I'm buying, say instead of n it was 4 oranges, like it says here, I know if I'm buying 4 oranges at 90 cents each, well, I've got to spend $3.60. It's 4 times 90. So okay, I know that it's 4 times 90, but it wasn't really 4, was it? It was n. So it must be n times 90, which in algebraic terms, we can call it 90n. Okay, fair enough. What about the next one? How many $2 chocolates can I buy with X dollars? Well, again, I might make up a number for X, maybe 10. Say I had $10, I know I could buy 5 of them. How do I know that? Because $10 divided by the cost of the chocolates, $2, tells me I could get 5 of them. There are 5 2s in 10. But again, it wasn't really $10, it was X dollars. So it must have been X on 2 must be my answer. How many chocolates can I buy? The amount of money I've got divided by 2. Yep, X on 2. The third one here, we've got how many $2 tickets can I buy with $80? I can see that I'm really asking how many T's are there in 80, so 80 divided by T makes sense to me. But okay, if it didn't, I would just say, well, again, make up a number. And I'm trying to make up a number that goes well with 80. So I've picked $8 per ticket. I've said if I've got $80 and it's $8 per ticket, I see that I can buy 10, because 10 8s is 80. So whatever way you think about it, then say, no, it wasn't really $8 a ticket, it was $2 a ticket. So how many tickets can I buy? 80 on T. So they're just some little methods just to work out, and it's in any of these word problems throughout this week. If you're unsure, you can make up a number and just think what you'll do in real life. You sometimes clam up when it's a letter, we free up and can answer it when it's a number. Here's I'm just introducing some terms in word problems. I might say this and this, which means they're added, or this, the sum of these two numbers, that's addition. The product of these two numbers, or this number times this number, that's multiplication. I've included quotient, but the truth is I won't use that in a word problem. How often do we go through the day saying, the quotient of this? Well, I don't. But it does mean division. Okay. Difference. If the difference between these two numbers is 7, I know that means subtraction. It's like if I said the difference between 10 and 4, hopefully you'll think it's 6. Yeah, difference is a subtraction. And if the difference between these numbers is 5, that means the difference of these numbers, maybe x minus y, is equal to 5. So hopefully that's mostly common sense. Maybe sum and product are specialised. Maths. Okay, so there's the general layout for solving word problems, which we'll come back to, but let's give it a brief look. Read the question more than once so you clearly understand what facts are given and what you're being asked to find. That's sort of the case for all questions, but particularly word questions. Don't read what you think it says, just slow down, read exactly what it says. Choose a letter to represent an unknown quantity that you want to find. It's only one letter in these, because at the moment we're only discussing single variables, so an X, an N, or whatever letter you pick, it doesn't matter. But there'll be something you're trying to find, and we'll name it. If we don't know it, we'll call it a letter. Use the relationships and facts given in the problem, and we translate those words into an equation involving the letter. We'll get there in a sec. We then solve that equation, and we just check to see, was that what we're after? Was solving for that letter, or was that letter just helping us to get somewhere else? So we're just going to make sure we answer the actual question. Now the first question we've got here is the sum of two consecutive numbers is 21. What are the numbers? Now I know that we could, by trial and error, we could find them. We could go through and say, well, first we might have to answer what's consecutive mean. That means one after the other. or just in a sequence, consecutive. Like, I know there's questions around like talking about consecutive even numbers. Well, what are even numbers? 0, 2, 4, 6. So they're still consecutive. 6 is the next one after 4. 4 and 6 are consecutive even numbers. So consecutive doesn't always mean 1, 2, 3, 4, 5, 6, but it means the ones in a row in some sort of series or sequence. You know, if there's a pattern, they're in consecutive order. Triangle, square, pentagon, hexagon, they're consecutive in a pattern. Anyway, point made. Clearly, consecutive numbers, without saying even or odd or anything, is just numbers that run after each other. So, no, I don't want to print it. You don't have to print it. So just, yeah. Okay, sum of two consecutive numbers is 21. Let one number be x. Now, does it matter if it's a bigger or the smaller number? Well, no. Because here clearly I'm referring to x as a smaller number, because I'm going to call the other number x plus 1. So if there's consecutive numbers, if one's 5, the other one's 6. If one's 13, the other one's 14. So if one's x, the other one is x plus 1. I could have said let the bigger number be x and the other number be x minus 1. Yeah, I could do that. Don't know why. I think it's pretty natural to go forwards, but I've chosen x and x plus 1. Now the question says that the sum of these numbers is 21. What's the sum of an x and an x plus 1? Well, that's what I've done here. X plus 1 must equal 21. That's exactly what the first sentence told us. Those brackets aren't doing anything because there's not a number or a needle out the front of the brackets. So it's just x plus 1 is 21. X plus x is 2. X plus 1 is 21. Take a 1 off both sides, you get 21 equals 20, and divide both sides by 2 to get rid of that times 2. You've got x equals 10. Alright, so I'll just make sure I answer the question. Did the question ask what was one of the numbers or what was a smaller number? No, it says what are the numbers. So one of them was the x equals 10. The other number was x plus 1, which must be 10 plus 1, which is 11. So there's my numbers, 10 and 11. And with word problems, don't just leave it as this. Well, in this case, I'd be wrong, because one answer wouldn't cut it. But put your answer in word for word problems back into words. Make sure you answer the question. Okay, let's do another one. The price of movie tickets is half as much for children as for adults. The cost for 4 adults and 3 children is $88. So there's 2 sentences so far, and each of those sentences contains some information that we need. Now, and then it says, what's the cost for an adult ticket? So it doesn't even ask me for the cost of a child ticket. Now, I've written 2 approaches on this one page. What I've started with is what I normally do. Whatever the question is, sometimes the question is asking for 2 things, so it doesn't matter as much which I define my variable as. But if it's just asking for the adult ticket, I admit I instantly go, okay, let's define that. Let X be the cost of an adult ticket. And if I was smarter, I probably would have said let A be the cost of an adult ticket, so I don't, lose track of it. I don't accidentally go, oh, is this the adult or the child ticket? Either way, you actually write this definition. This isn't just my example, what to do. This is exactly what you should do. Let X be the cost of an adult ticket. Okay, because when I start talking about X, I've got to have said what it represents. And the first sentence said, well, it costs half as much for children as for adults. So if X is the cost of an adult ticket, X on 2, X divided by 2 must be the cost of a child's ticket. So, okay, I've got my variables defined. Now the cost of 4 adults and 3 children is $88. In other words, 4 times the adult ticket cost plus 3 times the child ticket cost gives me $88. So 4 times the X plus 3 times the X on 2 equals 88. Well, I hope that equation makes sense. That's exactly what I'm doing. I know the prices. The prices are X and then X on 2. Remember that 3 is the number 3 on 1. Just when I times a whole number by a fraction, I want to remember that that whole number is still a type of fraction, but it's on 1. 4 times X is 4X. This fraction becomes 3X. So 3 times X on a 1 times 2, which is a 3X on 2, equals 88. Then I've said, well, let's get rid of this divide by 2 by timesing everything by 2. 4x times by 2 to become 8x. 88 gets times by 2 by 176. And when 3x on 2 gets times by 2, that just gets rid of the 2 on the bottom. That's why we did it. So I get 8x plus 3x equals 176. I know 8x plus 3x is 11x's. Now to get rid of this times by 11, I'll divide by 11, and I get x equals 176 on 11, which is 16. And since I defined what the question asked as x, there it is. The cost of an adult ticket, x is $16. Now why would I do it any differently? I do sometimes vary from my original tactic, because notice I had an x and an x on too. And dealing with fractions isn't always what we want. Often it's easier to not deal with fractions. So I could have gone about this and said, no, let's let the child's ticket be x, and the adult ticket can be 2x. So instead of naming the big one x and then halving it, I could name the small one x and then double it to find the price of the adult ticket. And that works fine. In actual fact, it looks like it was easier. Let x be the cost of the child ticket, hence 2 times x is the cost of an adult ticket, hence it's 4 lots of the 2x plus 3 lots of the x equals 88. I'm avoiding fractions. It's actually nicer. But I've got to remember that the answer to my question isn't x. I actually want to know what the cost of an adult ticket was. So my answer, don't forget to times your answer of x by 2. 4x plus 2x is 8x, 3 times x is 3x, that's giving me 11x equals 88. We divide by 11 to get rid of the times by 11. 88 on 11 is 8. Okay, so again, remember, it really asks what was the cost of an adult ticket. An adult ticket is 2 times x, which is $16. Okay, let's go for another one. A rectangle is 3 times longer than it is wide. I admit I go straight to this. As soon as I see word questions, unless it's clear, like I didn't draw a picture for movie tickets and that, I know how to buy movie tickets. But as soon as it became a little visual question, I drew a rectangle that looked about 3 times longer than it is wide. It has a perimeter of 192 metres, so all these 4 sides all around add to 192 metres. What are its dimensions? Okay, let's go through these words. Always look at what the question is actually asking for. In this case it's dimensions, in other words a length and a width. So I know I want that dimension and I know I want that dimension. So there's 2 things it's after. And here, look, it doesn't really matter. Once again, it's like the last question. I could define the length as x and the width as x divided by 3, or the width as x and the length as 3 times x. And here I'm going with that, what I feel is a smarter option, of just letting the smaller side be x and the larger side can be 3 times x to avoid fractions. So let the width be x metres. Well, if the width is x and it's 3 times longer than it is wide, that's why I get my x and my 3x. If it's a rectangle, if one width is x, the other width is x, I know they're the same length, otherwise it wouldn't be a rectangle. And if you're 3x, you're 3x. Okay, I've got everything defined, and now I can see that I can form an equation, because the other bit of info I got was it's all of these lengths add up to 192. So an x plus a 3x plus an x plus a 3x is equal to 192. 1x and 3x and 1x and 3x, that's 8x's all up. Divide both sides by 8, and I'm there already. X equals 24 metres. Don't forget in your word answer to include the metres. Don't just call it 24. Okay, practical problems need the practical answer, 24 metres. And I'll also check, did it just ask you for the width? No, it wanted the dimensions, as in it wanted the width and the length. So I've said that the width is 24 and I know the length was 3 times that. So the width was 24 and the length was 72. Perfect. Next, now these ones cause trouble. And I've done it 2 ways. I mean, my way is mostly the second way. Again, to me, laying it out like this is like a picture. But note, I've done this question twice, so let's do the stuff before that red line I just drew. My father was 28 years old when I was born. Okay? If he is now 3 times as old as I am, what are our present ages? Now, our ages are the unknown quantities. Okay, that's the things I want to know. And I've got choices. I could let Dad's age be X or my age be X. I could be, let Dad have been X 28 years ago. Look, there's different things I could do, but I'm just going for my age now is X. Let X be my age now. So I've written this statement. Okay, and I've just written here that now is important, because if X is my age, look, the question's talking about when I was born. I wasn't X when I was born, I was 0. I'm not defining X as 0. I'm just saying let X be my age right now. Okay, that's a fair enough variable to define. So right now, I'm x, my dad's age, is x plus 28, because he's 28 years older than me. When I was 0, as in I was born, this statement tells me that if I am whatever age I am, Dad is always 28 years older than me. That's not going to change. Okay, so Dad is now x plus 28. I can also say he is now 3 times as old as I am. Dad is also 3 times my age. So right now, today, Dad is my age plus 28, always, but also at this moment in time he is 3 times my age. And Dad's age today is one number. These have got to be equal. He doesn't have 2 ages today. X plus 28 must equal 3x, and that's what we've done. X plus 28 equals 3x. And then I've subtracted an x from both sides. My habit is to leave wherever there's more x's. There's only one x on the left and 2 on the right. I let the bigger one stay. So let's subtract that x from both sides, because 28 equals 2x. Let's get rid of this times by 2 by dividing by 2, and it tells me x equals 14. So right now I'm 14. My father's age is 3 times 14. It's 42 years. I also could have said my father's age is my age plus 28, which is still 42. Didn't matter which equation I went back into, whether I subbed it into 3 times my age or my age plus 28, I was still going to work out that Dad was 42 years. I'm 14, Dad was 42. Now, truth is, that's a really nice way to go about it. But again, I'm a visual person and I just like to lay out all the variables. Here is when I've done me and my father. My age now, I've defined the same thing. I still let x be my age now. So right now, I know that I'm x and Dad is 3x. The question told me that. Now, x years ago when I was born, I was 0. What was Dad? Well, I know that Dad was 28. Dad was 28 when I was born. So I know that Dad was 28, but I also know that x years ago, my age, x minus x is 0. Yeah, I was 0. How old was the father x years ago? What's 3x minus an x? It's 2x. And again, his age today, or his age back then, he didn't have 2 different ages. That 2x must equal the 28. So 2x equals 28, x equals 14. Okay, which is, yep, that's my age. And again, I do the same thing. The father's age was 3x, so I sub in Dad's 42. Now, I reckon that first method was easier in this specific question, but sometimes the second method will be easier. We've just got to jump in. These questions are worded differently. You're given different info. I still like laying it out like I've done the second one, but whatever one's working for you. But try and make sense of both of them, because if in a question trying it this way is just not working, maybe trying it this way will do. A lot of people want a set method. Tell me exactly what to do in a word problem. We can give you guidelines, but it really depends on the question. But part of my guidelines are, yeah, definitely write down all the info you've got, try and form equations, try and define a variable to avoid fractions. That's nice. If you've got a smaller number, let it be x instead of a bigger one. Okay, let's keep moving on. Now we've moved to solving equations for 2 variables. But because there's some confusion involved, first I want to say, ignore the words. Let's just solve some equations for 2 variables, just algebraically. And the first example I've got here, which I haven't gone forward and solved actually, I've just said, look, here's an equation with 2 variables, x plus y equals 5. Can I solve that? I can solve it with infinitely many solutions. I could say x is 2 and y is 3. They had to give 5. X is 1 and y is 4. Yeah. I could say x is 20 and y is minus 15. They had to give 5. So if I've got 2 variables in one equation, I can't get a unique solution. Okay? I've got infinite solutions. But if you give me a second equation with those 2 variables in it, and that second equation is different to the first, then there may be a unique answer that I can find. And in what I've written here, there is a unique answer. When x is 3 and y is 2, it works. 3 plus 2 is 5. And 3 minus 2 is 1. So that was one set of solutions that works for both. You'll find these called simultaneous equations. I haven't so much used this term here because, why? Well, because the notes when I got them didn't use that term, so I just carried on with it. But if you want to look up extra exercise or anything, yeah, these are called simultaneous equations, okay? Now, there are two methods of solving simultaneous equations, and that is the elimination method and the substitution method. And again, I've just carried on with what this course does when I inherited it, and I'm only using the elimination method. The substitution method. If you already know another method, which is called the elimination method, and you want to use it, you can use any method you want. But I'm just saying that in this course, we use the substitution method, and I'm just going to carry on with that, okay? But you're welcome to use any other maths you know or want to learn. Now, these instructions, well, let's go through with this example. We've got this example here. Name the two, well, actually maybe, no, I'll do this first one because I haven't written it out. Let's just write this one. X plus y equals 5, even though we know the answer, let's work it through. X minus y equals 1. Now it says first, name the two equations 1 and 2. Alright, you can be a 1 and you can be a 2. That's just so I can refer to it. Just makes life easier, I find. Now it says rearrange one equation to make one of the variables a subject of the equation and name it 3. Now, in other words, turn one of these equations into an x equals or a y equals. Now they're all single x's or y's. One of them's got a minus in front of it. Look, none of these look hard to rearrange to an x equals or a y equals. I'm just going to grab, I really don't care, I'm going to grab equation 2. I'm going to rearrange equation 2, and I'm going to turn it into an x equals. Because if I add y to both sides, plus y and plus y, well, minus y plus y, it's gone. And I get x equals 1 plus y. That'll do. I'm going to call it equation 3. So then it says substitute equation 3, the one we've just done, into the equation yet to be used, which in this case I haven't used equation 1 yet. So I'm going to sub 3 into 1. Alright? Because yeah, 2 I've used. Really equation 2 is equation 3, it's just rearranged. Okay, sub 3 into 1. Well, equation 1 had said x plus y equals 5. Equation 3 says that an x and a 1 plus y are exactly the same thing. So how do you substitute in? You look at this x and say this x here can be replaced with 1 plus y. If they're the same thing, well, there's equation 1, but instead of x, I've replaced x with a 1 plus y. Now I wrote boxes there just to make it feel nice, but really what I'm saying is 1 plus y equals 5. I've just put brackets around it. That's what we do when we substitute in algebra, we put brackets around things. But these brackets were really quite insignificant. Unless there's a number to multiply or a minus out the front, they're still just themselves. So what have I got? I've got 1 plus y plus y. Well, that's 1 plus 2y equals 5. And then I can say, well, I don't want this 1 here. I want to get the 2 y's at least by themselves, so I'll subtract a 1. That gives me 2y equals 4. I don't want that times 2 there, so I'll divide by 2. And I'll divide by 2. That gives me y equals 2. Now, don't forget, don't stop there. There's 2 variables. How do I get the other one? Well, then it says substitute the solved variable into equation 3 to find the value of the other variable. Because equation 3 has already been arranged to x equals. Equation 3 says x equals 1 plus y. But if I know y is 2, replace the y with a 2, and there's me, x equals 3, y equals 2. We knew them to be the answer. Let's summarise them. I don't need to do a word answer because it's not a word question. Just x equals 3, y equals 2, we'll cut it. We've just solved a 2-variable equation, otherwise known as a simultaneous equation, via the substitution method. Okay, so now we can look at some of these others. Look at the next problem. And I won't write the next problem all out because I've got this pretty version here. If I can just work the keyboard. This equation says x plus 2y equals 2 and 3y minus... I might start that again. X plus 2y equals 2, 3x minus 4y equals minus 14. Now, if I want to rearrange one of them to an x equals or y equals, I'm definitely zeroing in on that single x. Because it's easier to get a single x by itself because there's no number at the front that I have to divide everything by. I'm even going to be able to avoid fractions because I don't... Like if I try to arrange 3x to get to by itself, I would add 4y to both sides, but then I'd have to divide the 3 away. So it's definitely nice to go, if you've got a single letter in there, let's get x plus 2y equals 2 to just x equals. And to do that, I've got to take 2y off both sides. And what's 2 minus 2y? Well, it's just 2 minus 2y. I can't do it, but yeah, I've rearranged. And again, I've called that my third equation, even though really it is just equation 1 rearranged. So I've used equation 1. Then it says to sub that into the one you haven't used yet. So the one I haven't used yet is 3x minus 4y equals minus 14. Okay, here we say x is equal to 2 minus 2y. So here you see in red, I've replaced that x with a 2 minus 2y. And I put brackets around it because the 3 was multiplying all of that x. So the 3 will similarly multiply all of 2 minus 2y. So I've got to expand. 3 times 2 is 6, and 3 times minus 2y is minus 6y. Successfully expanded. Let's collect some like terms. A minus 6y and a minus 4y collectively is a minus 10y. Remember, it's not a positive, because that's like I do 6 steps back and 4 steps back. What have I done? I've done 10 steps back. 2 minuses only become a plus when you multiply them, divide them, or if the 2 minuses are next to each other. This is none of them. This is just number line. Back 6, back 4 is back 10. Now let's get rid of this plus 6 by minusing 6. And don't forget this minus 10y still owns its minus. We just took the 6 off. Minus 10y equals minus 20. What I said then is that y is being times by minus 10. What's the opposite of timesing by minus 10? It's dividing by the same number, minus 10. So when I divided the left by minus 10, it disappeared. When I divide the right by minus 10, well, minus 20 or minus 10 is a 2. I could have, if you didn't like that minus business, at this line here, I could have said, look, let's get rid of both minuses. It's like I could have said multiply both sides by minus 1, which turns that positive and that positive, and then just divide by 10. So that's more comfortable than doing it in one step like I've done here. That's fine. I've got a minus on both sides, that can go. Then I've got to remember I'm not done yet, because all I've done is found one variable. We go back to this equation 3 and sub it in. X equals 2 minus 2y, but the y is a 2, so it's 2 minus 2 2's, which is 2 minus 4, which is minus 2. We've solved it. X equals minus 2 and y equals 2. Great. Next one. Now this one is not really any different. In fact, it's a bit nicer. One of the equations is x plus y equals minus 2, and the other is y equals 5x minus 20. Fantastic. I don't need to do any rearranging because it's already given me a y equals form. So all I'm going to do is walk up to equation 1. I don't even need an equation 3. Equation 1, I'm going to replace that y, which I've got in red, with the 5x minus 20. Okay, you've just done my work for me. Thank you. The brackets are there, but there's only a plus at the front, so they're not doing anything, so I got rid of them. X plus 5x is 6x, and I've got a minus 20. Get rid of the minus 20 by adding 20. Minus 2 plus a 20 is 18. Get rid of this times by 6 by dividing by 6 gives me x equals 3. And then here I don't have equation 3 to sub into. My rearranged equation is equation 2, so I'll sub into that. Equation 2 is y equals 5x minus 20. The x is a 3, so it's 5 3's minus 20, which is 15 minus 20 minus 5. Sorted. That one's pretty nice. Not uncommon either. Now the next one will also happen when none of them are single x's or single y's, and we're going to have to get some fraction action happening. Since none of them are really, there's no single ones, it doesn't really matter what I pick. I've just picked an x equals for equation 1, so that'll do. Let's get equation 1 and get the x by itself. Firstly, let's take off the 3y by subtracting it. So 2x equals 7 minus 3y. Let's take off the 2 by dividing it. So 7 minus 3y all over 2. I've got something to replace x with. Unfortunately, it's a fraction, but I've got to live with it. I couldn't avoid it. Now I go back and sub that into the unused equation. The unused equation was 7x minus 37 is minus 16. And the rearrange said x was equal to what we've got in red here, 7 minus 3y and 2. Alright, then I like to say, look, we've got a minus 37. Let's just get rid of it. Add 37 to both sides. Fantastic, it's gone. Now I've got a times by 7 here. Instead of expanding it, let's just divide everything by 7. You're gone when I divide by 7, and 21 divided by 7 is 3. I've got to divide by 2. Let's get rid of the divide by 2 by timesing by 2. So 7 minus 3y equals 6. Let's get y equals on the left. Let's get rid of this plus 7 by minusing 7. 6 minus 7 is minus 1. Well, let's get rid of this divide by minus, this times by minus 3 by dividing by minus 3. And -1 on a -3 becomes positive a third. Again, if you don't like that, you could have made both sides plus and said 3y equals 1, so y equals a third. It doesn't matter. And then we just sub the third back into the equation. You can see we get to 3, so x is 3 and y is a third. That was the nastiest type we'll get. Unless you count word questions. A lot of people say that's the nastiest type we'll get. But in terms of a two-variable equation, yeah, that's it. That's a fair bit of marks in that, okay? Alright, so now if we do move to the word problems, it's still the two-variable stuff, and we're going to use this substitution method, but the questions come in words. We've got to make our own equations. Okay, the sum of two numbers is 200. If the bigger is 80 more than twice the smaller, determine the two numbers. Here I've gone for some intelligent labeling, where I've said let S be the smaller number and B be the bigger number. I could have gone X, Y. I could have said X is one and Y is the other, but I've just tried to really make it easier for myself because, yeah, I've got a smaller and a bigger being described. Now, if the smaller and the bigger number have a sum of 200, well, that's just smaller plus bigger equals 200. There's one equation. The next one's more complicated. It says the bigger, in other words, B, is 80 more than twice the smaller, which I've called S. So bigger is, you said it was an equals, 80 more than twice the smaller number. Yeah, that makes sense. The bigger is an extra 80 on top of 2 times the smaller. There's my other equation. And now we're just like before. And yeah, we don't need equation 3 because one of them's already rearranged to a letter equals. The second one's already B equals. So let's just sub B equals 80 plus 2S into the other one. S plus B equals 200. Replace the B with an 80 plus 2S. The brackets aren't achieving anything with only a positive 1 out the front. So we've got S plus 2S is 3S plus 80 equals 200. Take off the 80. 3S equals 120. Divide away that times 3. I've got S is 40. And now we just chuck it back into the equation which was rearranged. So B was 80 plus 2S, which is 80 plus 2 40s, which is 80 plus 80, which is 160. Alright, the smaller number is 40 and the large number is 160. Determine the two numbers, 40 and 160. The next one, this is probably, I'm going to say, the most common type, where you go purchasing stuff. But you've got a different shopping list as a friend. We want to work out the individual prices. Let's read the question. I bought 1 pen and 1 notebook for $2. Alright. I bought 3 pens and 4 notebooks for $6.80. Fair enough. From the same shop. Always keep it simple. Let's not think, oh, what if it was a bigger notebook or a different pen? Obviously we're being very simplistic here. They're buying the same stuff. Just different numbers of it. What was the cost of each pen and notebook? Well, I've gone smart again. I've let P be the cost of a pen and N be the cost of a notebook. So I can keep track. P for pen, N for notebook. Now, a lot of people write P equals pen and N equals notebook. That's not good variable definition, because what do you mean? P equals how many pens? Collier pens? What do you mean? No, cost. And the dollars is important too. Are we going to convert all these things to cents? You know, would you rather deal with 200 cents and 680 cents? Or are you okay with decimals and we'll stay with dollars? Your choice. I'm okay with decimals. I'm just going to stay in dollars. So if I've defined the cost of a pen in dollars as P and the cost of a notebook in dollars as N, if they cost $2 for one each, P plus N is $2. Well, that's interesting. I'll remove that. Your version probably won't have this. You don't put the units in there. You just put the numbers. I've defined the units. So units in the actual equations just make everything complicated. So hopefully that's gone. The other one said I bought 3 pens and 4 notebooks. So that's 3 times the cost of pen plus 4 times the cost of a notebook. 3p plus 4n equals $6.80. I've got my two equations. Now none of them are p equals n equals. But equation 1 looks easy to either get p equals or n equals. Doesn't matter, I've chosen p equals. If p plus n equals 2, let's take that n away from both sides. Ends up with p equals 2 minus n. Alright, and let's sub that into the other equation we didn't use, which was 3p plus 4n equals 680. Replace the p with a 2 minus n. Great. Expand the brackets. 3 times 2 is 6. 3 times minus n is a minus 3n. Plus 4n. Minus 3n plus 4n is just an n. I could write a 1 there, but it's just an n. Take the 6 away, And $6.80 or 6.8 minus 6 is just the 0.8. My N is, I know it's in dollars, my N is dollars 0.80. Call it 80 cents if you want, but the cost of a notebook is 0.8 of a dollar. Then we always sub back in to find the other variable. We sub back in and say, well, if the N is 80 cents, what's $2 minus 80 cents? It's $1.20. Cost of a pen is $1.20 and cost of a notebook is 80 cents, or however you want to write it. So yeah, that one is, yeah, pretty typical sort of one. And I've just repeated it here. The numbers I think aren't as pretty, but it's still just going and purchasing stuff. Costs $59 for an adult ticket and 2 junior tickets to a Knights game. Current pricing. It costs via the net. It'll cost more if you get it at the gate, like a lot more. So just buy it on the net first. Or get a season ticket. Why wouldn't you have a season ticket? Please. Well, okay. It costs $133 for 2 adult and 5 junior tickets to the same game. So clearly we've got adult tickets and we've got junior tickets. I've let A equal the cost of the adult ticket and J equals the cost of the junior ticket, so I can keep up with these letters. So it costs $59 for 1 adult and 2 junior tickets. Well, that's a single A plus 2 J's is $59. And then it's 2 adult and 5 junior tickets purchased make $133. So 2 A's and 5 J's is $133. You can see what I'm going to pick on. A single A. You're mine. I'm turning you into an A equals. So if A plus 2J equals 59, take the 2J away, it gives me A equals 59 minus 2J. There's my rearranged equation, which I'll use later. But I'll also use that to sub into the unused equation, which at the moment is equation 2. 2A plus 5J is 133. But let's replace the A with 59 minus 2J. Okay, so it's now, instead of 2 times A, it's 2 times 59 minus 2J. Span the brackets, 2 59's 118. 2 times minus 2J is minus 4J. Plus the rest. Minus 4J and a 5J just makes a J. Take the 118 away, J is 15. And then sub J equals 15 into equation 3. We get 59 minus 2, 15 is 29. We've got a junior ticket being $15 and adult ticket being $29. Go on, do yourself a favour. We've got more? Surely that's about it. Ooh, okay. Enjoy. I hope that made sense, and I hope word problems aren't as bad as they seem, or have maybe had seemed. I know the age ones are still tricky, but just write out the info you've got and enjoy. Okay, later.